Fellow, I am Professor Kha. Today we are going to explore the concept of relative velocity in a riverman problem, specifically focusing on the condition for crossing in the shortest possible time. Ready to dive in? Let's list what we know. The river flows fast at 5 meters per minute, and the man can swim at 10 meters per minute in still water. Your main goal is to determine the specific direction the man must head to cross the river in the absolute minimum amount of time. It is a classic optimization problem in physics. Look at the diagram on the right. They have the river velocity v sub are pointing east and the man's swimming velocity v sub that he can orient in any direction. Go cross, he needs a velocity component perpendicular to the banks. Notice how the vectors interact here. The time taken to cross the river depends only on the velocity component that is perpendicular to the banks. If O is the width, then time t is O divided by v subman times the cosine of the angle theta from the perpendicular. The maximum value of cosine theta is 1, which occurs when theta is 0 degrees. This means the man should swim directly towards the opposite bank, which is due north. In summary, to cross a river in the shortest time, always aim straight for the opposite bank regardless of the river's speed. In this case, that direction is due north.